Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 10 in the authentication module titled Offline Password Cracking. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, do a search on authentication labs, and select lab number 10 titled Offline Password Cracking. Alright, let's get started. This lab stores the user's password hash in a cookie. The lab also contains an XSS vulnerability in the comment functionality. To solve the lab, obtain Carlos's stay logged in cookie and use it to crack his password. Then log in as Carlos and delete his account from the My Account page, and then you're given credentials for a regular user account and then the victim's username. Alright, so the target goal over here is to obtain Carlos's stay logged in cookie, which contains his password hash, and then crack the hash and log in using the username and password that you obtained for the Carlos user. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all of my requests are already being passed in my Burp proxy. I am using the professional version, however, this lab doesn't require you to use the professional version, so everything that I do, you can perform using the community edition. Alright, so the first thing that we're going to do is log in using the regular account that we were given and just look at how the authentication function is performed. So the password was Peter, and then we have a stay logged in functionality, so let's hit login. It performs a post request right over here, which takes in the username, the password, and then the flag for the stay logged in parameter saying that it's on. And if you look over here, it sets two cookies, the stay logged in cookie and the session cookie. Now the stay logged in cookie over here doesn't look random to me, so it looks like it's encoded. So what I'm going to do is I'm just going to copy this and go to decoder, put it in here, and then click on decode as base64, and here we go. So definitely not random. It contains the user's username and then a colon, and this looks like an MD5 hash to me. So what I'm going to do is I'm going to copy this, and then I'm going to go to crackstation.net. I'm going to put the hash in here, and then say I'm not a robot, and select all the traffic lights, hit verify, and then click on crack hashes, and here we go. So it tells you that this is an MD5 hash, and the plaintext password of this hash is Peter. Okay, so first disclaimer is you should never put real-world hashes, so client hashes, in an online application because that's considered a breach of information. However, because this is an exercise, I'm using CrackStation instead of using Hashcat just because it's easier. Now the issue over here is the implementation for how the user can continue to stay logged into the application is done incorrectly. So the cookie over here contains the user's password hash, and if there's ever an XSS vulnerability in the application, what an attacker could do is attempt to steal this cookie over here. And if we go back to proxy, you could see the cookie doesn't have the HTTP only flag, so any JavaScript in the application can access the cookie. So that's exactly what we're going to do. We're going to try and attempt to access Carlos's cookie. So let's click on logout and look for a place in the application where we have an XSS vulnerability. So let's click on View Post. And here we go. So over here, you've got reflected input. So anything that you put in the comment field and possibly even the name field gets reflected in the application. So this is the perfect place to test for an XSS vulnerability. Now, the first place I'm going to test for is the comment field. So we're just going to test for a really simple XSS vulnerability. So alert 1 and then /script, which just pops a window with an alert that has 1 in it. And then we're just going to say test over here. Email is going to be test@test.ca. And then website is http://www.test.ca. And we're going to post a comment. And then we're going to go back to the blog and see if our XSS vulnerability worked, and it did. So you get an alert that has the integer 1 in it. So the comment field is definitely vulnerable to XSS. So the next thing that we're going to do is enter an XSS payload over here that steals the session cookie of any user of the system that visits this blog post over here. So the way we're going to do that is we're going to say script and then close the script right over here. And inside of that, we're going to say document.location is equal to, and that would be set to our exploit server. So if you're not familiar with a cross-site scripting vulnerability, there's a ton of online resources on it. It's essentially a client-side vulnerability that allows you to inject malicious client-side code, usually JavaScript, in the application to potentially perform harmful actions. In this case, the harmful action that we're performing is stealing the user's cookie. So any user that visits the post, it'll attempt to steal the cookie and send it to our exploit server. So this is the exploit server that the application has provided for us. And so we're going to use that. So we're going to say every time anyone visits this page in the application, I want you to visit my exploit server. And when you do that, I want you to grab the cookie of the user and append it to my exploit server. And that's essentially it. So on the exploit server, we're going to have access logs that check every time someone does a request to the exploit server. So every time anyone visits this page, it'll perform a request to this link over here and then append the cookies of the user to the link. So let's just say test.ca over here. And then the website, http www.test.ca, just in case it does any validation on the format. So let's click post comment. Now let's go to our exploit server and then go down, go to the access log. And over here, so far, it doesn't look like anyone clicked on anything. Let's look at the access log. Okay, so far no one has clicked. Let's reload it again. And here we go. So it looks like we've got more resources. Let's look again, and no one clicked. So I don't know how often that robot runs, but it should run every couple of seconds, which means that my exploit didn't properly work. So let's go back to the lab and view post. Click OK. And look over here. So it looks like it did see it as JavaScript. So if we go over here and then go to document.location, and I know what my issue is over here. So I wrote this incorrectly, which is why it's not working. So let's copy this again, paste it in here, and the issue was with this. It should be a single quote and a single quote. And then again, let's just say test, and over here, test.ca, and then the website is http test.ca and post comment. Now this should work. Let's go to the exploit server and then go down, go to access log and see if the user will will view the page. And so far, I'm not seeing any cookies from the user. Okay, so again, let's go back to the exploit server. And this is how real hacking works. You have to keep customizing your exploit. So let's click on view post, click OK. Go down and view the content over here. So we've got to document.location. This is the incorrect one. And then we have a second one. And I know where my issue is over here. I made another mistake. So let's copy this. Hopefully this is the last mistake I made. Okay, so this should be over here. So the idea is you've got your exploit server over here, and then from there you add a document.cookie. I was just missing one single quote. Hopefully this should work. So test.ca and then http test.ca post comment. And then we go to the exploit server, go to access log, and see if that worked. And here we go, it did work. So you can see over here, it called the endpoint /exploit from the IP address 10.0.3.6. That's the IP address of the user that visited the post, which looks like it's an internal IP address. You could see over here that user had 2 cookies. So there's a secret cookie, which I'm not sure what that is because I didn't see it when I logged in with my regular user. And then there's a second cookie, which is the stay logged in cookie. Now, this is the cookie that I care about, so I'm going to copy it. And I'm going to close this, go to CrackStation. And actually, before we go to CrackStation, let's go to Decoder. Put it in here, and you could see it decodes it to Carlos and then the MD5 hash of Carlos. So we're going to copy that, put it in here, say I'm not a robot, crack hashes. And you could see the password of the Carlos user is once upon a time. So now we have both the username and the password of the user. So let's close this and this, and then go to my account, put in the username, which is Carlos, and then the password, which is once upon a time, hit login. And here we go. We access the Carlos account, and if we reload, we should see the congratulations, you solved the lab. And actually, we don't see it because I think we need to delete the account. So let's delete the account. Say once upon a time, and then click on delete account. And here we go. So it says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the vulnerability manually. Now, we usually script the exploit in Python, but because this requires an exploit server and it was a combination of 2 vulnerabilities, we won't be scripting the exploit. In the next lab, we'll look at another case of a broken authentication vulnerability.